In this video, we're going to follow the reaction of potassium chlorate turning into potassium perchlorate and potassium chloride. Given these delta H of formation values, entropy values, and delta G of formation values, go ahead and calculate through both routes the delta G and compare how close the two calculations are. Go ahead and pause and then come on back and we'll work through it. All right, if you're back, remember the two ways to solve this is that we can get the delta G naught of the reaction just from the sum of the products of the delta G naught of formations minus the sum of the delta G naught of formations of the reactants. Additionally, your delta G of any reaction is going to be equal to the delta H of that reaction minus T delta S. So let's work through both sets of these. Start with, let's do the delta G route. Well, my products is going to be negative 409.2 for my potassium chloride plus 3 times negative 303. So 3 times negative 303.2. That'll handle my products. I'm going to subtract from that 4 times negative 296.3, which will calculate out at minus 133.6 kilojoules per mole. If we want to perform this through the entropy and enthalpy route, I need to find the delta H of my reaction, which again is the sum of the formation products minus the sum of the formation of reactants. So in our case, that'll be negative 436.7 plus 3 times negative 432.75 minus from that the reactants of 4 times negative 397.7. This will give us a negative 144 kilojoules per mole for the delta H naught of the reaction. We're also going to need the delta S. Again, the sum of the products minus the sum of the reactants. 82.59 plus 3 times 151.0 minus 4 times 143.1 for negative 36.81 joules per mole Kelvin. If we then want to solve the delta G naught of reaction this route, it's going to equal the delta H naught of the reaction minus T delta S naught of reaction. At standard state, it's 298, so our temp will be 298. Negative 144,000 joules per mole minus 298 times negative 36.81 joules per mole Kelvin. This will be minus negative 10,969.4 joules per mole for a final delta G naught of reaction of negative 133,031 joules per mole, or negative 133 kilojoules per mole, off by 0.6. So these are very well in agreement with each other, just slight rounding errors in the data in the table that lead to very slight differences in our calculations. In this case, we had multiple of the reagents and the products. We had to account for the number of moles, so we had to multiply the values by the number of moles of those chemicals to obtain our final value of negative 133 kilojoules per mole for the Gibbs energy for potassium chlorate turning into potassium perchlorate and potassium chloride.